Please welcome Frank Nagle, who is a research scientist at MIT's Initiative on the Digital Economy and advising chief economist at the Linux Foundation. Frank studies how competitors collaborate on core technologies by competing on products and services, especially in AI, open source software, and cybersecurity. Today, he will explore the role of open models in the AI economy. Please welcome Frank Nagle.
Thanks so much. It's great to be here with you all. Thanks for having me. I'm excited to be a part of this particular session on the drivers and consequences of AI and growth in the AI space, because as you'll see, I think that open has a lot to do with this. And so what I'll do today is I'll kind of start more broadly and talk a bit about openness in tech in general, and then dive into some new research that nobody has seen before, so you're the first audience to see it. So if it's terrible, let me know and we won't show it anywhere again. If it's great, then we're off to the journal it goes tomorrow. I'll also point out, as Mert said, I'm here at MIT, but I'm also at the Linux Foundation, so I sort of wear two hats. Anything I say is on my own behalf and not Linux's, although Linux certainly supports a lot of openness in technology. So why should we study openness in AI? First of all, I think to this crowd, this is no surprise, but AI is a general purpose technology and is reshaping a whole bunch of things that we care about in the economy, right? So science, knowledge, and production, as we heard from Christina earlier today. And so, but what's a little bit different about AI as a GPT is that it sort of has this dual-track nature to it, where we have frontier innovation happening, but also diffusion through GUIs and APIs. So prior GPTs, we can discuss and argue around the edges, but things like the printing press or computers were embodied in some sort of physical technology that had to diffuse as well. But with the way that AI is structured, yes, you need a computer or a phone to kind of run it, but once you have that, and everybody already did, for the most part, it diffuses much more quickly, right? And so when we think about diffusion of this particular GPT, it's a little bit different than what we've seen in the past. And where openness comes into play is that we sort of argue and can think about how it may increase the speed of diffusion. And so when we're talking about the rate of AI growth and all these types of things that we're talking about today and tomorrow, openness, which I'll define in the context of AI in a little bit, but think about it as model weights or code or data. I'll get more into those details in just a moment. But this affects who can actually participate in the AI economy and how quickly and widely it diffuses. So we all know, if you haven't heard the story about vitamin C and curing scurvy, this is one of my favorite stories about innovation and the lack of invention and the lack of diffusion. So long story short, at some point we didn't know that vitamin C cured scurvy. A scientist discovers that citrus can essentially prevent sailors, this is back in the 1800s, 1700s, from getting scurvy. They discover this, but then it takes almost 100 years before it becomes standard operating procedure to carry a barrel of oranges on a ship with you so that your sailors don't get scurvy, right? And so when we think about the process that we care about and what's happening in technological diffusion, there's the original invention, and then there's the actual diffusion of it worldwide, and we can't have this big impact until these types of inventions diffuse. And what I would argue broadly, and this is not just me, but that more openness will speed up diffusion, and that's what we're going to argue that we're seeing in the context of AI and LLMs as well, is that the openness of some of the models is allowing for faster diffusion and a broader and larger impact more globally. So very brief history, I'm not going to go into details of all of these, but openness has been an important part of technology for a long time, in particular here at MIT, as well as many other places. But the early pieces of the internet were very open. They were open standards, and the networking structures that were led to much later the internet were open and were shared and collaboratively developed. We also, of course, have the Linux operating system. This wasn't the first piece of of open source software, but it has become one of the most important, developed in the early 90s. The Apache web server, which came out of some of the government supercomputing centers. I'll talk briefly about some work that Christina's advisor, as well as my advisor, Shane Greenstein, and I did on this, to think about how we value the open source and the open nature of these types of technologies. And then GitHub, which is essentially where open source sort of lives today, really sped up. One of the things that I think is important to understanding the diffusion of AI, or the platforms that are behind the AI systems in this diffusion. GitHub is really where open source helped, or the platform of GitHub helped open source diffuse and make it easier for kind of global collaboration. And then there's this sort of long-running joke that OpenAI is not actually open. It turns out they used to be open. So the earlier GPT models that OpenAI released were actually pretty open and accessible. Then they sort of closed up, and then just this past summer they started releasing some newer open models. And then of course, and so we're kind of fast-forwarding to today. Meta releases Llama, which is an open weight model, and again we'll kind of discuss how that's different. And then I hadn't heard this before, just doing some research for this presentation, but DeepSeek, which was an open model coming out of China, that really kind of shook a whole lot of the AI industry just earlier this year when it came out, because at least they stated that they had spent way less on creating this model and training it and doing everything that we need to do than many of the kind of US-based companies have said that they've spent on this type of stuff. And so I heard DeepSeek described as a Sputnik type of moment where all of a sudden, at least from a kind of US-centric point of view, we realized that China was much closer on the AI kind of frontier than to the US than we had originally realized. And meanwhile, on kind of the open side of this, we see the openness of DeepSeek really leading to a whole lot of adoption and a whole lot more innovation on top of it as well. And so, open standards really enabled the internet and the computing revolutions. Open collaboration lowers entry barriers for startups, for individuals, for researchers. And the economic literature has shown that there's these links between openness and sort of the speed with which innovations diffuse. So that's sort of openness in tech more broadly. I'll briefly talk about the economics of open source software, which is an area those of you who know me this is where I spend most of my time. But while we're in an academic institution, so I have to give you a pop quiz. Does anybody know Jean Tirole, who won the Nobel Prize a few years ago? He was an MIT PhD grad. What was his second most cited paper at the time when he won the Nobel Prize? I'm not going to wait for hands because nobody's going to know this. But it was called Some Simple Economics of Open Source. And it was written with Josh Lerner from HBS. And I will say, as far as economics papers go, there's basically no math in this paper. There's no numbers, there's no math. And Jean Tirole also had a PhD in mathematics. But a nice paper that sort of set the stage for how we can think about the economics of open source. Why would people volunteer their time to create these types of products that anybody can use? And I think that they were focused on individuals' motivations at that time. Today, we think about why would companies pay their engineers to write code that their competitors can then use for free, right? And so there's a lot of kind of economic questions around open source and the activities there. I will say that having now done this for a while, I get why they didn't do any math or any numbers, because if they did, they would have had to retitle the paper Some Not So Simple Economics of Open Source, because in open source land, in economics, we think about price and quantity as kind of two very important pieces of a puzzle in how we measure a technology or a product or anything that we're trying to measure. Here with open source, usually P is 0, it's free. You can freely distribute it, you can edit it, you can copy it, you can do whatever you want with it. And as a result of that, Q equals, we have no idea, because just as an example in sort of the corporate context, a company could download something like Linux or Apache once and then copy it 1,000,000 times within their environment. And us as kind of the researchers only see that download happening once, and it's very hard to measure how much of this stuff is actually out there. And so, myself and others have spent some time over the past decade trying to understand how can we measure the value that this stuff actually creates. So I mentioned Shane and Apache. So we looked at this one piece of open source technology It was easier to measure because web servers are designed to be connected to the internet, so we could just scan the internet and see how many of these things were out there. And we estimate, it's kind of a wide range, but that the value here is between $2 and $12 billion for this one open source project, and this was, a decade ago. Since then, a few other folks have tried to measure some of these types of things and broaden the scale with what they're looking at. Knut Blind and co. have looked at the open source that was created in the European Union at the point of 2018 and estimate that creation cost was about $1 billion, €1 billion. And then a group from the NSF here in the US did something similar, looked at the open source created in the US in 2019 and estimated it was at about $38 billion. And so then what we did most recently, and then this is a much bigger number, and so it's caught some news over the last year or two, is that we looked at not only, sorry, let me take a step back. These two studies basically looked at what would happen if all open source was deleted and we had to recode it from scratch, right? And then put it back up there. This is what the cost would be to recode all the open source coming out of Europe, all the open source coming out of the US. The problem is then that's completely missing Q, and we have no idea how much of that is on the demand side. And so what we did for this more recent paper is thinking about the thought experiment where what if open source didn't exist at all? Not only was it deleted, but we can't redo it, right? The whole thing doesn't exist. And therefore, every company who uses this stuff would either have to recode it from scratch themselves, or they would have to pay somebody else and buy it. And that's where we end up with this much, much larger number of almost $9 trillion in the global economy as the value of open source. And oh, by the way, this is definitely an underestimate because we're not looking at things like operating systems and some other things. We're only looking at the most widely used kind of open source building blocks or packages, right? So when if you're using Python or R and you install a package, that's the type of stuff that we were looking at here because we could get this kind of quantity data on that in some reasonable way. And so now, as we move into thinking about AI, keep all this stuff in the background, but remember that open model AI doesn't actually necessarily mean open source. And so when we talk about open model AI, we sort of think about it in 4 levels. In the prior talk, Yutaro was talking about the way that these models are designed and trained. We can think about the neural networks having, once they're trained, they have weights, and that's how we can, the model knows how to infer things from its training data. So some models at kind of I guess it's at the top, but kind of at the lowest level of openness, there'll be open weights. And so we cannot see the source code or the data it was trained on or some of the other things, but we can see the weights. And that allows us to sort of run these models at home, right? And we can do these things, if you have a supercomputer in your basement, you can run Llama 3 yourself, but there's smaller models that you can run on a laptop. Or if you're a company, you can run them on your own servers and things like that. Then the next level of openness would be open code. So something like Mistral, and not all the things that they do, but some of the things that they do, they actually release the source code, and so you can actually see how the model was developed, how it handles data, how it has guardrails or not, and all these types of things. So that's a bit more open. And then this is more of a sort of rarity, but some organizations and some models also have open data. And so the data that they are trained on is also open, which means we as kind of everybody else who didn't make the model can better understand, is there any biases in the data, or are there any weird things in the data? We can actually see how it was, trained as a result of the open code, but we can see what it was trained on as a result of the open data. And then finally, the kind of true or the most open form would be something called open governance, where we actually see a shared and kind of collaborative governance of designing the model and creating the model, and more ability to interact with the model and tweak it and customize it and all these types of things. And so all of these, and we don't see too much of that. There's this group Eleuther AI that would be the furthest along in that. And so all of these are open in some way, and we can nitpick as to what the definition of open source is, but important to know that there's varying levels of openness, and that's going to be important for some of the things we do. We'll lump this together for the most part in the study that I'll get into in just a second, but we can think about these in different ways and how we think about diffusion as well. Lastly, I mentioned GitHub is kind of where open source lives. If you don't know Hugging Face, this is where open model AI lives. There's over 2 million open models that are, again, open in some dimension on Hugging Face, as well as over 400,000 data sets that are open so that you can train your own things and experiment and do your own things. And in my retirement career, what I want to do is start a company where an emoji is my symbol for my company. So that's the actual symbol for the company, is the Hugging Face emoji that you can send on your phone. So this stuff is huge. They also have about 10 million users, and there's about 50,000 companies that are users of this and are using open models. So when we think about kind of the drivers and the scale of the economy, of the AI economy here, this openness and where, again, sort of where openness lives is going to be an important piece of it. So now I'll sort of dive into the study. This is joint work with Daniel Yu, who is a former PhD student and is now at Georgia Tech. And so where we started with this whole thing is that we sort of saw, we were playing around with some data and looking at some things, and we noticed this puzzle. And so we've already kind of heard that AI is important, and in particular we're going to focus on large language models, which we also heard about in the last talk. So I won't spend time talking about that. But an important thing is that the public sees these types of things as chatbots, right? So ChatGPT is what people think of when they think of kind of AI and LLMs and all these types of things. But importantly, the stuff that's happening in the chats is not particularly what we as economists would think about as productive work, right? So you're asking it for help with a recipe or to come up with some activity for your 5-year-old on a rainy day, which are important things as a parent of young kids. Those are important, but they're not necessarily adding value to the economy in measurable ways, in the ways that we think about. And recently, I think David Deming's going to be here tomorrow to talk about actually that paper in particular. But one of the things that they looked at was that when they looked at what ChatGPT is being used for, is that only about 30% of stuff happening on ChatGPT is actually related to work. The rest of it is unrelated to work. I will caveat, and I'm sure David will tomorrow, that this is only from the consumer-facing side of ChatGPT. So like enterprise accounts, which for example MIT has an enterprise account, wouldn't show up here. And so this is perhaps not overly surprising, but this is what people think about when they're thinking about AI usage. Importantly, where we think is going to be the biggest advances here are more on the API side of things, so application programming interface. This is where people can actually build tools or applications or all sorts of things, or do research and really hammer these types of LLMs at scale rather than just having one-off sort of conversations with ChatGPT, right? And so this is something that we're seeing ramping up, especially with, we've all heard about AI agents coming down the road, or maybe they're already here, but as we saw in the last talk. But those types of things are going to be very reliant on these types of API calls, where at scale we're sending requests to these types of LLMs for broader inference. So the puzzle that we sort of noticed while playing with, looking at some of the data on this stuff, and I'll talk about that more in just a second, is that LLM's capabilities have increased very rapidly, right? So we have lots of benchmarks that we can compare them on, and the capabilities have increased rapidly, but these API prices have basically stayed sort of static. And that's despite its increasing capabilities costing more and more money to actually get there, right? And so how do we think about this sort of puzzle? Is why aren't we seeing increasing prices as model capabilities improve and as costs get higher? And we think, and I'll make some arguments, that open models can help explain this in a very sort of fundamental economic way. Their existence kind of keeps a lid on the prices that people can charge, and also allows more competition in the market for AI inference. So I've sort of touched upon some of this, but and in the prior talk, this was touched upon as well, so I'm not going to do too much here. But what's important in the context of closed versus open models is that after these models are trained, the models create outputs based on prompts, which if you've used any of these things, you understand that. But that's generally referred to as a process called inference. So when I talk about inference, just think about it as you're prompting these models to do something. It's not what they were trained on, but you're asking them something that they're going to infer from their training what the answer is. And so the key distinction here that we're going to focus on is whether models are closed, where there's not really any details publicly about them, and they're sort of in this black box, versus open models, again, lumping those different levels of openness together. And the biggest difference from an economic standpoint here, and we'll see this in the data, is that when you do this API call at scale, for closed models, you have to be bouncing off of OpenAI servers, just as an example. If you want to use O1 or any of the OpenAI models, when you do that at scale inference, it's going to have to go off of OpenAI servers. Or in the case of OpenAI, they have a contract and an agreement with Microsoft to handle some of the scale as well. But Microsoft is contractually obligated to charge the exact same price that OpenAI does. But in the open space, what we're going to see is that any company, if you've got a bunch of GPUs and a bunch of servers, you can set up your own kind of storefront and allow other people to run inference off your servers at any sort of scale. And so because of that, we're going to see a whole bunch more companies entering to essentially allow us to run inference at scale. And as a result of that, this is Econ 101, there's more competition for these types of things because there's more companies that are actually serving this. Whereas here, at least within an individual model, you essentially have a monopoly. And so therefore, we're going to see lower prices in this context, at least in part because of larger competition for this inference providing. Okay, so I will probably run out of time, so I'm going to highlight the results right here. But basically, we use data on about 1% of the global revenue for AI LLM inference. It's not everything, certainly, but it's not nothing. And then what we end up finding is that the closed models really dominate the LLM inference economy, both in usage and revenue. I'll show you some things behind that. And also, the closed models have greater performance, but the open models catch up quickly, and that speed of catching up has been getting faster over the last year or two. And then when we think about this interaction, I sort of already talked about this, but the existence of open models creates more competition and drives down prices. And what's interesting too here, and I'll kind of speculate on this towards the end, but these open models, once we kind of do some back of the envelope calculations, create about $70 billion of unmeasured value. And they're underutilized in a way that I'll get into the details of, but more people should be using them. And it offers an additional sort of $15 billion of unrealized value. So the $70 billion is kind of unmeasured, and then there's this sort of unrealized potential consumer welfare we could think about of $15 billion too. And this is in a market where the estimates are that in the year 2025, about a little over $100 billion will be spent on this in this type of space. So these numbers aren't in the trillions like the other thing I mentioned, but this is getting close to kind of 100% of what we would expect, or the scale of 100% of what we'd expect to be happening in the market this year. How am I doing? What do I have left? 20 minutes left? I was good. Really? Oh, great. All right. So I talk really fast, and now I'll slow down a tiny bit. So the empirical setting here is that, wait, 20 minutes for the whole session or just for me?
Yeah. So 8 minutes for this talk and then for the Q&A.
Perfect. That's what I thought. Okay, great. So I'll keep talking super fast. Great. So the empirical setting is this platform called Open Router. If you're not familiar with it, it's the leading platform for this type of activity that we're talking about, LLM inference. And think about it as kind of if you as the end user, as a researcher or an app developer or a company, you don't want to have to spend a whole lot of time writing new code to just swap from one model to another, right? So if you want to use OpenAI's latest model and play around with that with your data, your environment, your research, but then you want to swap over to something like Meta's Llama model or DeepSeek, that would normally require you to write a whole bunch of code. If you're working with Open Router and using their platform and their libraries, that swapping is very, very simple. It's just change a couple of lines of code, and you're all of a sudden using a new model to do whatever it is. So if you want to try to test out these models, see which ones are better for your AI scientists that we just heard about, or for whatever it is you're doing as a company, Open Router is a great place to be. And we've seen this, we can see this because they've existed for about a year and a half, but they really only kind of super ramped up over the last 8 to 12 months. And they now have over 4 million global users. They have 500 AI models that you can choose from. So they sort of fade out models once they become less popular. And they're acting as sort of this marketplace. And so on the other side of them, you have 60 inference providers in that way that I was talking about. If you're using an OpenAI model, you have to have your inference being done on OpenAI or Microsoft servers. But if you're using an open model, then you're going to be able to select from a whole bunch of different vendors that are offering that model and offering different prices. So again, based on industry estimates, we're relying on kind of the powers that be to estimate the size of the AI inference economy. But the estimates are that for the year of 2025, there's about $108 billion going to be going into this type of market. And based on the revenue numbers that we can see from OpenRouter, they have about 1% of that revenue that's happening from AI inference. And they're, just for knowledge, we're lots of us are business schools. Their business model is they just simply take a 5% cut of the revenue going through to the inference provider, and the rest of the finances or the rest of the money is passed on the inference provider. So this is actually useful for us because when we're comparing prices of these types of things, all we have to do is subtract 5% and like that's what the price that the inference provider is actually getting, right? So it's not like they have different deals with OpenAI or some of the smaller inference providers or things like that. They just have this flat model that makes our lives a little bit easier. So what did we do? We collected data on the prices and quantities, and this is, I think, the last definitional word I'll do, but in LLMs, we talk about tokens as a measure of quantity. That's roughly equivalent to one word in an LLM prompt, right? So when you write whatever it is you're prompting, your favorite LLM with, each word roughly is called a token, and pricing in this world happens at millions of tokens. So we observed data for about 5 or 6 months. Again, this was like a point where they had really ramped up and they had millions of customers and millions of users. And we're going to merge this data with model level data for LLM benchmarks. So this is how we're going to measure the capabilities or the performance of these different models and think about comparing, again, the open models and the closed models. Here we actually have about 2 years worth of data. So when we're kind of only comparing stuff about the model performance, I'll talk about this 2-year window. But when we're talking about prices and revenues and things like that, it'll be this kind of 5 to 6 month window of a very recent history. So I sort of teased these 4 main results that we have. So here's result 1. With the closed models, which are in gray, we originally had the closed models colored and the open models gray, but my employer, the Linux Foundation, so we have to gray out the closed models and highlight the open models. But I'll point out that these are, except for this one, these are all log scales. And so when you see, just as an example, Google and XAI and Anthropic and OpenAI on this top left in terms of the usage numbers, these are log scales, and so they are orders of magnitude higher, even though it doesn't quite look like it on the graph, than any of the open models that are being used. With revenue, we see this to an even more extreme degree. But again, the usage and the revenue is being dominated by these closed models. Now, in panel C here, we can see these are sort of the price histories over time within a model series. So as you may know, there was GPT-2 and then GPT-3 and then 3.5 and 4 and 5. And so we sort of track the prices of these over time, and you don't see too much pricing change within a model family. And if anything, you sort of see prices go down over time within a model family, which again is sort of a bit of a surprise, given that the costs are actually going up as the capabilities get better. And then lastly, this one just shows, again, within model family, the benchmark capabilities go up and to the right, as we would expect. So performance goes up and cost goes up, but price stays roughly the same or goes down. And so now we're going to try and look into the existence of these open models and better understand if they're kind of keeping these prices in check in some way. Before we do that, we'll talk about these capabilities. Again, I sort of teased these results before, but when we think about, these are 3 main benchmarks that lots of people use for benchmarking these LLMs against each other. We've used a handful of others, but these are kind of the 3 most popular, but they're all pretty consistent. consistent. What the top row here shows in the blue is that the open models are always behind in terms of capability, but they catch up fairly quickly. Over the period of the last 2 years, the range for catch-up has been between 10 to 40 weeks. However, that time is getting faster, so the gray sort of dotted horizontal lines show you the average time of the leading open model catching up to the leading closed model is going down, right? And so that's, the gray lines are kind of the average over the course of a year of how long that catch-up takes. And it's getting down to, to where today in 2025, it's between 10 to 15 weeks on average that it takes open models to catch up to the same performance of closed models. And then on the bottom here, we can think about the capability gap. So how big is the gap in terms of these benchmark performance between, again, the leading open model and the leading closed model? And it's kind of fluctuates and goes over time, but the time that we're going to be particularly focused on for the pricing data is actually this kind of last 5 or 6 months of this period. And here, the difference between the best open and the best closed models is only about 10% or lower on average. Two last results to show you. So result 3, this is that sort of market demand. So the red models are the closed models, OpenAI, Anthropic, most of Google's models, for example. And the blue are the models that are open, so Meta's stuff, Qwen, DeepSeek, these types of things. And what we have here on the horizontal is the number of providers that will actually do that inference for you and will do the legwork of actually running whatever it is you want to run. And you'll see that almost all the red folks, the red models are 1 or 2 providers. With Anthropic has a couple, but when you a couple more. But when you look at it, it's like they're hosting stuff on Amazon, US and Amazon, UK or EU or whatever. So it's really they just have these, and all the prices for all of those are the same. So really, when you think about the closed models within model, you have a monopoly, right? And so there's one price charged, even if there's multiple providers. With the open models, we see up to 19 of these places that you can actually run the inference on, and as a result, we see a much wider dispersion in prices, right? So for the same, just to pick something kind of random here, Meta Llamas 3 Instruct, you'll see a range of prices and the lowest of those would be almost 5 cents per million tokens, whereas in the more monopoly type of world, way up in the top, we have OpenAI's O1 Pro being charged at over $150 per million tokens. And so the scale of again, this is a log scale for pricing. So the more closed models, the less competition, and we have faster and faster, and more competition for the open models. So I'm getting the wrap up sign. I knew I was going to run long, but the last result is that we take these and sort of all this data, you don't have to look at that. And we basically do the thought experiment, two thought experiments. One is, what if we forced everybody who was running on a closed model to Pareto improve themselves and move to an open model that is at least as good on the capability side or better? What would the cost savings be if we moved them all there? And they're using models that are more expensive than they need to use. We end up estimating that at that $15 billion across the economy of potential cost savings that's not happening. And then for that final piece, we do the thought experiment of what if the open models didn't exist at all, and everybody who's already using open models had to swap to the closest closed model. The average price that people are paying would increase by about 1,300%, and consumers would spend about $70 billion more than what they're spending now on inference if the open models didn't exist at all. And that doesn't account for this competition angle, because more likely than not, the closed models would actually increase their prices as a result of this, and so it would be even higher than this. All right, so we're gonna kind of wrap that and leave that there. And I'll point out here, this is, we think it's a kind of a continuation of something that's happened for decades, where corporate especially, nobody ever got fired for buying IBM or Microsoft because they're kind of the safe, alternatives. And we think that's continuing in the space of AI, where people are sort of suboptimally choosing closed models when they could be using open models that are actually more capable and much cheaper at the same time. All right, thanks so much.
Okay, we'll take some questions. Okay.
Hi, thanks. Are you able to say anything about the total supply of compute, because that would affect inference prices, right?
Like the global supply of compute?
Like that Open Router has access to, like.
So importantly, and sorry, I was going too fast. I should have deleted some slides. But so OpenRouter has basically like 0 servers, right? So they're just a sort of a pass through to these other inference providers, and that's sort of understating things a little bit. But like, so the inference providers. So the answer to your question is no. But just to make sure we're on the same page, like they pass it on to these other inference providers who actually do the inference, right? And so I don't have it. We don't have any data on like this. We have some data that we've used in some like as sort of controls and regressions. We can see like network latency and a couple of other types of things that people might care about when they're choosing which provider to use. Price being the biggest one, but some other network characteristics as well. But we don't see like total server capacity of the providers, unfortunately.
Thanks.
Hi, this is an incredible data set. So I have a question about the framing. So what do you think are the mechanisms where people are like making the wrong choice? I guess I come from the econ world where we like believe in revealed preferences. So it seems like it could be like there's a difference in some other variable like latency, why people are choosing models, or it could be security where people trust OpenAI, but they don't trust some former Bitcoin miner who's now hosting like Llama to protect their data.
No, it's a great question, and I will hat tip to your colleague Andre Fradkin, who was actually the first first academic to sort of stumble across this data set, but he doesn't care about open stuff, so like we were like, hey, let's go do open stuff with this thing that Andre found. I don't think Andre's here, but to your point about the mechanisms, this is anecdotal, but I have had a lot of conversations with companies, with governments, with other people who say we can't use open models because then our data would be open to the world. And I'm like, wait, what? That's what you think is going on? And you know, and then again with my Linux hat on, like I have this conversation of like, look, it's actually sort of the opposite. When you use OpenAI servers and run your stuff on their servers, you don't know what they're doing with your data. You can have agreements and blah blah blah, and like hopefully they're doing what they're supposed to do. But with the open models, you can run it on your own servers if you want to, but you can't do that with something like, you know, the GPT models because it has to run off of there. So I think you know, and we're trying to do a little bit with this, but from the mechanism standpoint, we think it's sort of this still kind of misunderstanding about what openness is and like how it actually works. And so I've had that conversation with too many like high-level people at companies and governments, and that would be my guess is the main mechanism.
Hi, very interesting research. So from the perspective of industry, having made decisions about using open source packages or resources versus buying, you know, off-the-shelf code, I think in industry there's this common viewpoint about the maintainability of the software over time. So and of course you have very big numbers for the missed opportunity of savings for using open source. How did you account for, let's say, things like maintainability of open source over time and the risks there?
It's a great question. And so I think that when, you know, this is sort of back to Aaron's question on the mechanisms, right? Often when we think about open source versus closed, the closed is going to be more user-friendly, we'll say, on many dimensions, right? So better, you know, user interface, better maintainability, all these types of things. At least on sort of the user interface type of side of things, you know, again, Open Router is nicely for us as the economists solving that problem, because you as the user of this don't have to do anything different to swap from from an open model to a closed model, right? And so the usability sort of factor doesn't factor in here. The concerns about the long-term sort of maintainability and is this gonna, you know, sort of blow up because it's open and things like that, that's you know, I think something that may be factored in there. Although I will point to when OpenAI released GPT-5 and within ChatGPT, you were no longer allowed to choose your own model. Everybody, like, you know, there was won't drop profanity, but like there was a huge, everybody was upset because they couldn't do what they were doing before, right? So it caused all these sorts of problems from a, not maintainability, but from a usage consistency standpoint, and that was something that was 100% closed, right? And so, so agreed. I think this goes back to the mechanism question, and there's some piece of it, the front end type of thing, there's no difference, at least in our data set of this type of usability, but agree with the long-term maintainability, that may be another reason why people are choosing more expensive models, even if they're the same capability or lower capability in the closed ones.
Hi. So for finding three about the competition reducing prices, um, could this also be explained by just smaller so open source models take less compute to generate tokens, and so that reduces the cost instead of the competition factor?
Yeah, so that's a good question. It's a very good question. We haven't. I'm just trying to think about if we have the data to answer that at scale, right? So there's, maybe you have the answer that like, I don't know that open models are necessarily kind of cheaper to run on the compute side of things. They may very well be, and that would certainly be a piece of, I would agree that that would be the kind of the lower piece of this. I don't know that we have data to answer that, but we can certainly look around and see if anybody's sort of done that analysis.
Yeah, maybe normalizing by parameter count.
Yeah, exactly, right? Like, yes, we could definitely do, actually, good point, because we can see the number of parameters. That's right, yes, thank you, that's a great idea.
So very interesting. One question. So your numbers all refer to sort of the size of sales of people who are providing inference services. Basically, I guess you can't call them ISPs,
Yeah.
but inference service providers.
That's right.
But my question is, surely there's enough users out there with sufficient scale to actually rent their own Amazon cloud GPUs and services and run their open models on their own, and
Yep.
you're not capturing that, I take it.
Yeah, so that's like one last, I ran out of time, but these estimates are definitely underestimating the kind of true size of this for exactly that reason, right? You can even without your own access to a cloud, you can download open models and run them on your laptop, right? Some of these smaller parameter models and things like that, and we can't see that. I will say that we're in conversations with a number of the cloud providers right now to try and get. We can't see what you're running on your laptop, but we may be able to see what people are running in the cloud, and sort of seeing a different layer of this and a different approach of this, and hopefully a wider swath of it. And so that's on the agenda for this, and this is the data we have at the moment, but the hope would be that we can do something that's much broader scale by working with the cloud providers. But then all sorts of lawyers get involved, and it takes much more time.
Frank, thank you very much.
Great, thank you.